Okay, let's take a look at this Unit 4, Day 3, Transformations of Quadratic Functions. All right, for those that have me as a teacher, this is homework 41. So all this revolves around writing all these equations in this specific format, right? With this new 4p in front that we were looked at yesterday, combined with the part of vertex form we already are familiar with h and k being the vertex. Okay, so really this is about playing with this 4p value, also known as the length of the lattice rectum, or the LLR, we're going to call it. So we'll just do each one and make sure you can go through and understand each of these on your own, not just write down the answers, but understand how to do them as well. So we're going to start each of these by just writing the equation using that 4p format. So for instance, here we have the negative right here on the x squared, but in this 4p format, the negative will be in front of the y here. So I'm going to rewrite this as not just negative y, but negative y minus 0. Just to point out that the vertex here, when there are no numbers being added or subtracted, it's going to be 0, 0, which means this is going to start at the origin, right? There's no translation in either direction, up or down, or left or right. So translations, we're going to put none. And once these have numbers other than 0, we'll have translations up, down, left, and right. And our vertex is 0, 0. So step 1 is everything we just did in the blue. Step 2, let's go to red. We are going to look at finding this p-value. Right? So this value in front, which is negative 1, negative is the same as negative 1. Remember, this is equal to 4p, right? And that's the length of the lattice rectum, the LLR. So if I want to find out what p equals, I'm going to solve 4p equals whatever this value is in front of the y parentheses for each problem. Okay, so the 4p stays the same, and the number it's equal to will change. So we have to solve 4p, which doesn't change. Sorry, that's going to be 4p, not negative 4p. And equals negative 1. Now, the negative is not so important. This just lets us know right here that the parabola is going to open down. So we do get a value of p equals negative 1/4, but really we ignore the negative for now until we graph. We really just focused on the 1/4 value, which means the distance from the vertex to the directrix and the vertex to the focus is going to be 1/4, a unit away. Now, since this is opening down, this is very important, we need to know, well, from top to bottom, what is the correct order of these 3 points on the graph. These are all in the graph right here. So since it's opening down, recall that the directrix should be above, okay, and the focus should be below. So we go directrix, vertex, and then the focus. So we have the directrix, which is going to be a 1/4 unit up. So I am going to count by quarter units here. Right, so there's my directrix, and this is going to be 1/4 unit. So technically this would be, the next one would be 2/4, 3/4, 4/4, and so on. That way we can graph these a little bit easier. And likewise, I'm going to go down 1/4, and that's going to be the focus, which is a point. So my directrix equation, right, is going to be 0, starting at the focus and going up 1/4 unit. So basically, it's going to be 0 plus 1/4. Which is just 1/4. Y equals 1/4. That's the equation of this line. The focus right? We'll always have the same x coordinate here. So these two must be the same in order for them to line up vertically. However, the y coordinate is going to be 0, the y here, and this time minus the p-value, which is just negative 1/4. Right? And these two here and here are always the same. And again, this 1/4 came from right here. That's why we use 1/4. One's positive, one's negative, because one's above and one is below. Of course, if we're opening the other direction, the plus and the minus will be reversed. To find the directrix, we're going to subtract. To find the focus, we will add. It just depends on which direction it's opening, up or down. All right, so lastly, we need to graph using our 4p value. So we kind of go back to where we started this all, and we look at this and say, well, that's a length of 1, which means from the focus, half will be to the right, half will be to the left, because the whole length is 1, half plus 1/2 will equal 1. Now, much like we counted by force on the vertical, we're going to count by force on the horizontal as well. Like with 1/4 and negative 1/4, and then 2/4 and negative 2/4, which of course equal a half, but I'm just going to write it like that. So I need to go a half to the right and a half to the left, so that this whole value right here, right, should be the same as here. Of course, just the positive and negative only lets us know it's opening down. And then finally, we can go ahead and graph or sketch our parabola. Okay, that's pretty good. We'll use that. Okay, let's take a look at the next one, number 2. Same idea. Let's put this in our format, which it looks like here, this one is actually already there, except for that it's missing the one in the front, our 4p. That's the only part that's missing. So on here we can see our vertex. Let's see here. We got y minus 2. Let's just make this x minus 0. So our vertex is going to be at 0, positive 2. Right here. So this is translated up 2 units. And our p-value, again, we're going to take our LLR. Right? It's going to be 4p equal to that number. So p again equals 1/4. If I divide both sides by 4, and that means we have to go, it's opening up this time because it's positive, which means the directrix will be directly below this time, not above, 1/4 unit below, right through there. That's just an estimation, of course. So it's this time it's going to be, since the LR is below the vertex, it's going to be 2 minus 1/4, which is 7/4. Right? And for the focus will be 1/4 above. So it'll be 2 plus 1/4, which is 9/4. And of course, the x-coordinate here will always be the same as the x-coordinate of the vertex. So you can expect to see these two always be the same. And finally, we have our width here through the focus is of 1. So we could say we can go half this way and a half this way. So it's very squeezed in. We could probably have used a different scale, made it a little bit bigger, but this will do. just like that. There we go. Okay, let's do number 3. Now you can see this is very far from the form that we want to have. So recall that we want to have 4p, some number, positive or negative, parentheses, and then y, and then plus or minus some number, right? And then we have on the other side just parentheses squared. So we have quite a few things that are not correct here. The only thing that is correct is that we have this part. But you can see here the +6 does not belong in this format. And on the left, we don't have a number with parentheses and y plus or minus, right? So we need to do a little bit of work to get to be correctly formatted. So let's, since that 6 is not belonging on the right-hand side, right? There's no plus or minus some number after the format here. We should get rid of it. So we'll have -2y minus 6. Okay. And that's looking a little better. And now the right-hand side is just as it should be, some x minus some number squared, so that's good. Right-hand side, we still don't have parentheses, so our goal is to have this, y plus or minus some number with a value out up front, right? Which basically means we need to do a GCF. Take out a -2 from each of these, and you'll be left with y plus 3 on the inside, because this has to multiply back to this. So -2 times y gives us -2y, and now -2 times +3 is what gives us the -6. So that's how I got 3, because these two have to multiply to the number directly above it. And on the right-hand side, that stays the same. So we had a little bit of work to do to set this up here, right, to get in the right format before we did anything else. So our vertex now is at 1, -3. Right, so it's translated right 1 unit and down 3 units. Okay. P-value is going to be always 4p equal to, this time, -2. And -2 is coming from whatever value I have here, those always match. So if we divide both sides by 4, once again, it's always divided by 4, right? We'll get 1/2. And it is negative, which just means it opens down. That's the only thing the negative means. So this will be close to number 1, where the directrix is above the vertex, right? So we have, let's see here, 1, 3. 1, -3 is right here. And the directrix will be 1/2 above that. Okay, so I'll go up 1/2. There's my directrix. And the focus will be 1/2 below. So here's the focus. And it has a width of 2, right? That's from here. Ignore the negative, just the width of 2, which means I have to go 1 to the right and 1 to the left. Right? That's the length of the LLR right there. And then my graph goes like this. So the directrix is above, so I need to add from the vertex to get that equation. I need to add my p-value to go up. So -3 plus 1/2. Right, that'll give us -5/2. Focus will be always the same x-coordinate, 1, and then we'll have -3 minus 1/2. So I'll have -7/2. Now, if you're not sure on how I'm getting these fractions, -3 plus 1/2 and -3 minus 1/2, and I'm getting -5/2 and -7/2, if you're not sure about that, go ahead and find a calculator that has a fraction button on it, and then you can see just by plugging it in, like right here, you can plug in -3, right, and then plus, and then it'll have this fraction button. Sometimes it's A over B, this one's N over D, but a lot of calculators have this, whether you realize it or not. And let's see here, I want to put in +1 over 2. Right, you just move the cursor down the bottom and hit enter. Right, and there it is, -5 over 2. So if you're not quite sure, just check on the calculator. There's no reason to get the algebra problem wrong because of a 5th grade math problem, which is adding 2 fractions. Okay, so if you're not sure, just double check. And after a while, just by doing enough of these, you'll get the hang of it. You'll see the pattern and it'll become easier for you. Okay, let's look at number 4. So let's write this in the format here. We got 4 y minus 0, and I'll put these with the h and k in there as zeros. So we have a vertex of 0, 0, and no translations, not moved up, down, or left, or right. Right. We have our LLR, so it's going to be 4p equals 4. So finally we get a non-fraction p-value equal to 1. So we're going to start at 0, 0, right? And we're going to go, since it's opening up, my directrix will be below, right here, down 1. And the focus will be up 1. Okay, so directrix, let's see here, since it's down 1, right? Our vertex, y-coordinate of vertex minus 1 will be -1. The focus is just up 1, so we'll have +1, and of course the x-coordinate is the same as the vertex. These always match. Right, and using the LLR, we know it's 4, which means the whole length is 4. We got to go 2 to the right, 2 to the left, right? Because the whole length will now make up 4. That's where this value comes into play, the very end graphing. Then we can plot the parabola. There we go. Okay, hopefully this is getting easier now. Let's look at number 5. Already have the proper format, everything's there, so I can grab the vertex. We have -2 and -3. And that means they're translated, let's see here, left 2 units and down 3 units. Our p-value, which is 8, have 4p equals 8. So divide both sides by 4, the p-value here is 2. So starting from the vertex at -2, -3, so left 2, down 3. And opening upward, I'm going to have a directrix that is below by 2. So we can draw that right here. And I'll have a focus that is up 2. And with an LLR of 8, that means 4 to the right, 4 to the left. 1, 2, 3, 4, and 1, 2, 3, 4 to make 8 total across. And we can go and graph this. There we go. And our directrix, since it's below, it will be the vertex, the y-coordinate of the vertex minus our p-value. So we got y equals -3 minus 2 is -5. And then it will be our focus point will be our y-coordinate k plus p-value, so -1. And of course, the x-coordinate not that. X-coordinate is the same as the vertex. So these will always match. If we wanted to graph, just know that this is the p-value we keep talking about. This is what is equal to 2. Each time we get a p-value, it's to help us graph these points. Okay. Here we go. Let's look at here. It looks like this is in the proper format pretty much. I can rewrite a few things. Notice how the negative is on the right-hand side. I'm going to put it over here on the left. And instead of x squared, I'm going to write x minus 0 squared. So it's very clear that our vertex is at 0, 1. It is opening down, right? Because of this, it's negative. That's going to open down. And the translation will be just 1 up, 1 unit up. And we got a LLR of 12. So I'm going to have 4p equal to 12, which means the p-value is 3. So I'm going to go 3 up and 3 down to get the directrix and the focus. Now this time it's opening down, so the directrix is actually above. 1, 2, 3. Okay, and the focus is now below. 1, 2, 3. So it's always good to have a picture to help us figure that out. So our directrix this time was up p-value. So if we take our y-coordinate here, or k, add a p-value, we'll get 4. And then for here, we'll take our p-value, subtract our p-value from here, and we'll get negative 2. Right, 1 minus 3. And the coordinate is the same for the x. Right, using the LLR, which is 12, I can go 6, half of it, 2, 4, 6 to the right, and 6 to the left, 2, 4, 6. That will give us a length of 12 total. Right. So this whole thing is 12. That's where we use this LLR. And then we can graph it. Let's see here. There we go. All right, so front side's done. Let's flip it over to the back. Okay, so pretty good shape right here. I don't think we need to write the format quite as clear anymore. I think it's given now that we know that this is a 0 for the vertex. So I'll have 0, negative 2, which means it's translated down 2 units for the vertex. So we're going to go down 2. Find that p-value. So same as the last one, number 6. It's going to be equal to 12. So our p-value again is 3. But it's opening up, so that means the directrix is below. 1, 2, 3 this time. So we'll subtract 3 from our vertex to get this equation. Using a straight edge. Right? So we'll have y from negative 2 down 3, negative 3, negative 4, negative 5. Right? Negative 2 minus 3, which means the focus must be up 3. Negative 2 plus 3 would be at 1, with the x-coordinate being the same as the vertex. LLR is 12, which means 6 to the left again, 6 to the right. 2, 4, 6, and 2, 4, 6. Draw a nice smooth parabola through the vertex. There we go. Okay, number 8. Like we're opening down this time. I always see that negative right away. So I can see right here, that's going to let us open downward, -4. So translation, we'll have a vertex of, looks like 4 and 1. So we're going to go, let's see here, right 4, units, and up 1 unit. P-value is going to be 4p equals -4, or just 4. So the p-value is going to be 1 in this case. All right, so we can graph our vertex. We're going to go to 4, 1. So right 4, up 1. And directrix will be above, because this is opening down. So I know directrix is going to be above at 1. And the focus will be down 1. Be right here on the axis. And from here, we need an LLR of 4, which means 2 to the right, 2 to the left. So 2 to the right, I'm going to kind of go off the graph right here. Alternatively, I guess we could have counted by 2s. That would have kept us on the graph instead of counting by 1s horizontally. But that will work just fine. There we go. So directrix is above, so that's plus. So from here, we're going to have to add 1, right? That's just 2. And focus will be below, so 1 minus 2, or 1 minus 1, sorry, 1 minus p, 0. And always the same x value, 4. All right, when we get to 9, you might recall back earlier on number 3, here, we did have a problem that had some numbers on the outside, and we had to do some extra work. So it looks like number 9 is very similar. So let's do that extra work again to get the right format. So let's move this plus 8 out of the way. So we have, let's see here, 2y minus 8 is now x plus 1 squared. And we need to pull out that 2 from here, GCF, and get y minus 4. So 2 times y is 2y, and 2 times -4 is -8. From here, we can graph our vertex. We have -1 and 4. So translated right 4 units. Oh, sorry, nope, translated down. Let's do this again. Translated left 1 unit. Looked at the wrong number here. And then up 4 units. There we go. So left 1, up 4. Pretty close to the top of the graph here. And our p-value is going to be, let's see here, we got a 2, so we got 4p equals 2, so only a p-value of 1/2. Divide by 4 on both sides, 2 over 4 is 1/2. So we're just going to go down 1/2 for the directrix, and then up 1/2 for the focus. There's our directrix. And then using the LLR, we know it's a 2, so I need to go 1 in each direction. 1 this way, 1 this way. There's our graph. And our directrix will be, let's see, directrix is below, so I got to subtract 1/2. Here's if you're not sure, you can use a calculator. So we'll get 7 over 2. And then for the focus, it'll be plus 1/2. So it'll be 9 over 2 with the same x-coordinate, -1. And let's go down to the next row. Almost there. Once again, we're on the wrong side here with this plus 2, so we can move that over. -y plus 2, right? And then take out this -1, so we'll have y minus 2. So a little bit of work to get this to be the proper format. Again, if you're ever not sure, just go ahead and multiply it back together. It should equal what it has above. So -1 times y is -y, and -1 times -2 is +2. Just do a check by going backwards. So we have a vertex of, let's see here, 1 and 2. So we're going to translate 1 to the right and 2 up. P-value is going to be 4p equals 1, or -1. And so it looks like we're back to, like on number 1 and number 2, having this very, very small p-value of 1/4. So from our vertex at 1, 2, we're going to go barely up, just 1/4, to get the directrix. There we go. Right there, and barely down to get the focus. And it's only going to be 1/2 to either side, because we have a LLR of 1. I need to go 1/2 to the right, 1/2 to the left. There we go. Equations will be, okay, the directrix is above, so it's going to be my y-coordinate plus 1/4. So that's going to equal 9/4. And the focus will be 2 minus 1/4. So that'd be 7/4. With the x-coordinate being the same thing, 1, 7/4. Don't be afraid to use that calculator. If you're not sure, you just punch in, right? 2 plus fraction 1/4. Hit enter. There it is, 9/4. Just to double check and make sure. All right, almost to the end. We have already in the proper format. We can find the vertex pretty quickly at -1 and +1. Right? So we have, let's see here, this is going to be left 1 unit, and then we're going to have left, and then right. Nope, right, and up 1 unit. There we go. Our p-value will be 4p equal to the LLR to 6. So if you divide both sides by 4 here, we get 6/4, which equals 3/2, which for graphing purposes is like 1.5, 1.5, up and down. So we can start. Let's see here. Start at our vertex at left 1, up 1. We're going to go, let's see, opening up, so the directrix is below, down 1.5. So down 1, and then another 1/2 would be right here. and then going up a half plus a little more. Using the LLR, we're going to go 3 to the right, 3 to the left to make 6 total. So 1, 2, 3, and then 1, 2, 3. Right there in the middle. We have our vertex, just like that. Directrix, let's see here, since it's down, it's below, we're going to do 1 minus 1.5. So we'll get y equals just negative 0.5, or you could say negative 1/2, either way. For the focus, we'll have 1 plus 1.5, which is 2.5, right? Or 5 over 2, either way. And then the x-coordinate is the same as the vertex, negative 1. So either one of those will be fine. And lastly, for these types anyway, we need to once again solve so we can have the right format. We can add 16. So we'll have 8. I'm going to do both steps at the same time. I can take 8 out of both of these, right? 8 out of 8y will leave me with y. 8 out of 16 will leave me with positive 2. So as you do this more, you can probably combine a few steps. Just be careful not to go too fast, too quickly. So our vertex is going to be, let's see, negative 3 and negative 2. So that's left 3 and down 2 units. Left 3, down 2. Let's see here. This is opening up, so our directrix will be below, but by how much? So we got 4p, and this time it's going to equal 8, right? So the value in the front here. So divide both sides by 4, and our p-value is 2, a nice number. So directrix will be below, down by 2. Get that straight line. Try that again. There we go. And then the focus will be above by 2. And then to get the length of 8, I need to go 4 to the right and 4 to the left. 1, 2, 3, 4. 1, 2, oh, that's 1. 4 to the right and 4 to the left. Very cool. All right, connect this. There we go. Directrix will take, again, it's below focus, so a vertex, so we're going to go down by the p-value. It's negative 4. So y equals negative 4. And then we're going to add to get the focus. So negative 2 plus 2 will give us the 0. And of course, our x-coordinate is still negative 3, always the same as the vertex. There we go, and that's our final graphing of this style. Now, the next ones are more of a reversing the process and just seeing if you can come up with an equation that matches this, and just sketch it. We don't have to be exact here. They don't give us enough information to figure out what the p-value is, so we can just use 1 or negative 1 as the p-value. So these are, in many ways, a little bit easier than what we just finished. All right. So translation up of 3 units, so up is going to be the y. So we'll have y minus 3 to go up. And to the left 1 unit will be, to the left would be plus 1, and then squared. And that's all we're really getting at here. So we'll have translated up 3 units to the left, and then up 1 unit. And then it'll just look something like this. Same thing here, translated 4 units to the left, and then down 1 unit. And it looks like, yeah, and we'll just assume that's opening up. So we'll have, let's see here, y to move down 1 unit will be +1, and then to move left 4 units it will be +4. Yeah, there we go. And again, we're not worrying about a p-value at this point. All right, so here it does say translated 1 unit to the right. Okay, so that's left to right. It's going to be x minus 1 squared. The y isn't translated at all, but it does say reflected over the x-axis. So if this is the x-axis, reflected over the x-axis would look like this, right? So reflected over the x-axis is the same thing as opens down. You just have to draw the picture. You can see once you reflect it, it just means the parabola opens down. So you want to take this phrase right here, reflection over the x-axis, and translate it into opens down. Okay, same thing. So that just means that p-value needs to be negative. So we'll have, let's see here, 1 unit to the right and opening down. Yeah, just something like that. And that will conclude this video.